We still have more libraries to learn for Hadoop. We're getting to the end of the line, but there are a few more key ones, and one of them is Mahout or Mahout. It depends on who you ask. This is a very sophisticated and special purpose library. It's used to perform predictive analytics on Hadoop data. Another way to talk about predictive analytics is to say machine learning. And still another way is to say a superset of data mining. Now, it's really kind of an interesting problem space. I actually done quite a bit of production work in this space. You can either use a library like Mahout against the data in a Hadoop cluster, or you can use other machine learning specific languages on a much smaller subset of the data. It's a very sort of interesting space, and you want to really have a great understanding of your business problem because, as you might expect, more complicated and sophisticated algorithms like Mahout have much more overhead in processing. And when you're processing with a very large or huge amount of data, you want to have a really compelling business case because you're spending money for this processing. So what are the common categories of data mining algorithms and some examples, just so you can kind of get your head around this if this is new for you? They fall under three groups. The first is recommendation. And a business case for this would be Pandora or a Spotify. So it's likelihood. If you've created a playlist in Pandora or movie recommenders, it's based on massive amounts of data, not only on your own, in this case, music or movie watching habits, but on people like you. So the algorithm will allow recommendations to be produced. Another one is classification. And a use case on this is IDing what is a spam email. So you use known data and you use new data. Now, it's different from recommendation because classification is you're predicting a new discrete value, whereas recommendation, you're predicting an existing value, but a new instance of an existing value. It's a subtle difference. And then the third major type of data mining is clustering. And this is just grouping items together. So Google News is an example of this. What's under technology news, what's under health news, can it be automatically categorized so it's easier to find it? So again, this is a very, very high level description of machine learning. But as more and more behavioral data is collected, this factors into more and more of the big data solutions. The interesting thing about the Mahout library is it's designed for Hadoop scale processing, as opposed to many other machine learning libraries, which really were designed to run on a single desktop. The R language is probably the best example of that. The R language is sort of the opposite of Mahout because it's designed for a single user with a really small set of data. I could easily teach a full day or even a full week course on Mahout, but I'll just give you a couple of high-level concepts. First of all, when you're working with data mining algorithms, you generally process the data as vector. And so you do matrix access or matrix operations, matrix multiplication on the data. So you'll be importing and setting up the data as vectors. And if your math is rusty or you haven't had stats class in a few years, I would really recommend you crack out the stats book or go to something where you could learn stats online, because if you're not able to understand the algorithms, you're not going to be able to provide business value. And really, you can. It's just a question of time. Again, as I said, data mining algorithms fall into general categories of recommendations, which is predicting a value, clustering, which is grouping, or classification. And within each of these categories, there are a number of different algorithms in the Mahout library. Last time I checked, there were over 20, and I think it's more than that now, 20 different algorithms that will implement these various types of data mining activities. So it requires a level of sophistication of understanding statistics in order to get business value that I don't want to gloss over because it's really important in the implementation. So if you do decide you want to use Mahout with your Hadoop cluster, you will usually add it to a Java project. And the recommended way to do that is to add the Mahout library or jar file to the Java class path. The example shown in the Apache Mahout library is to do this via Maven, via the POM file, although there are a number of ways you could do it in Eclipse via the GUI, but that is the suggested way to do it. In terms of optimization of data mining algorithms, again, this is a very sophisticated topic. It usually revolves around parallelization and setting the appropriate size of the data set. Interestingly, as the stats community has become united with the big data community, there's been overlap between the traditional statistics language, which is R right now, although there's some work around this new language called the Julia language, which scales a bit better than R. And there's actually a library called the R Hadoop library, which if you happen to have fluency in the R language is an alternative to the Mahout library. Now, I haven't tested it in production. I have played around with it, and I am somewhat fluent in R, and I actually prefer using R Hadoop personally to Mahout. And again, because machine learning libraries generally aren't part of any distributions, you have quite a lot of flexibility. It's not like you have to uninstall something to reinstall something else. You just sort of pick the library. Again, this is a very active space in terms of development in the Hadoop ecosystem as more and more data projects require machine learning. So if you're going to use any of these libraries, kind of like I told you with Impala, you want to go out and do some research, find out what products, new libraries, new optimizations, because a lot of people are working in this space so that we can get more meaning from the big data that we store in Hadoop.